Welcome to our 7th lecture in Computer Programming Part 2. We are going to look today at abstract classes and interfaces, and we're also going to revisit polymorphism. So again, these are some very important concepts in computer programming. So I want to review something we talked about in our last recording, which is the separation of variable type and object type. Up till this point, we've always assumed that the variable type is the same as the object type. But now we learn that's no longer the case. We can have a variable that holds an object that is a different type, as long as the object type is a subclass of the variable type. And let me show you what I mean. Here's our class diagram for the example that we've been working on. We see that car is a superclass, and it's extended by Neon, Cavalier, and Prius. So car is the superclass type, and Neon, Cavalier, and Prius are all subclasses of car. Now, because of how inheritance works, that means that Neon, Cavalier, and Prius can access all of these attributes and this method here, because a subclass has access to all of the non-private attributes and methods of its superclass. So what we can do then is we can say car my car equals new car. In this case, we're saying that the variable type, car, is the same as the object type. How do we know which is which? We declare a variable with a name and a type, and that's very important. So the name is my car, and the type is car. And we assign to it an object by using the equals sign. So what's on the left is the variable declaration. What's on the right is the object declaration, or in other words, instantiating an object and storing it into a variable. In this case, the object and the variable type are the same. We know that's legal, so I'm going to color that green. See if I can give it a lighter green. Okay, that works. Now, car my car equals new neon. Now, here's where we get into a difference between variable type and object type. And again, the rule is that the object type can be a subclass of the variable type, or it can be the same as the variable type. The reason is, and this is very important, the variable type tells us what methods we're allowed to call. We are allowed to call any methods on the variable myCar as long as they exist within the type car. Okay? So the variable type tells us what methods we're allowed to call. Now the object type will actually tell us what behavior will happen when we call that method. In Neon, it's pretty straightforward because Neon simply inherits all the methods from car. In Prius, it's a bit more tricky because remember that Prius overrides the go method of car. Override, not overload, override. Override means we have a method in the superclass and we have the exact same method in the subclass. Since we have it in the superclass car, we're allowed to call it because that method exists in car. But since we're overriding it in the subclass Prius, if I invoke mycar.go and the object is a Prius, it's actually going to use the Prius's go method. So that's the benefit of having a variable type and an object type that are different. The object type can override methods from the variable type and give them more specific definition. Now these are all three legal, so I'll go ahead and color those. Car my car equals new Cavalier. Sure, that's fine because Cavalier is a subclass of car. How about this one? Neon my neon equals new neon. Is that legal? Sure it is, because the variable type is neon and the object type is neon as well. Okay. Now, Cavalier my Cavalier equals new Cavalier. That's fine. Okay, Cavalier my Cavalier equals new car. Let's think about this one. The variable type tells us what methods we're allowed to call. The object type actually tells us what will happen when we call those methods, or as we say, the object type will tell us what behavior will happen. So what variables or what methods are declared in car? The getters and setters for our odometer, miles per gallon, gallons of gas, plus go. What about Cavalier? We have an additional method called set convertible, and then a companion is convertible. That only exists in Cavalier. It does not exist in car. Does not exist in car. Therefore, this is not legal, because if we tried to invoke set convertible on this, the object type doesn't have a set convertible method because the object type here is car, not Cavalier. The object type is car, and that object does not have a get and set convertible method. Same with our last option. Prius is a more specific type than car because Prius has extra logic. Extra logic for things like set miles per milliamp hour that a normal car does not have. We can't have a variable of a more specific type and then an object of a more general type. That simply won't work. So that is also not legal. Expect to see this on a quiz. This is an important concept, so there's a good chance you'll end up seeing this on a quiz. Now, because the variable type tells us what methods we're allowed to call, and the object type tells us what behavior we'll get when we call those methods, there's an interesting trick that we can use, and this is called abstract classes. If you go into the slides for this course and then go to inheritance and then abstract classes, you'll see some information we're going to talk about here. Let me try and squish this together. Actually, I'll tell you what. I'll just move this over like so. Okay, so what we can do is I'm going to pull up NetBeans here. We can have our superclass define a method without giving it any behavior. In other words, without giving it any logic. And that method can be declared abstract, which means that the subclasses must implement that method. For example, take a look at this. We have some statements here in our output. Car before running, odometer 10,000, blah, blah, blah. We don't know what type of car this is. It could be a Cavalier or a Neon. We do happen to know it's a Prius because it reports the battery level in an overridden method. But it would be really nice if we had, say, the type of car in this statement somewhere. Maybe the manufacturer, the trim level, something like that. But how could I do that? Because if I have in Neon, say, if I have in Neon, I'm going to add a method, public string get manufacturer, okay? Or let's say get model. Okay. Return Neon. Something like that. Okay, if I define this down here in my subclass Neon, it's not visible to the superclass car. Okay, so I go to car, and let's say that I want to add to my toString method state equals get model plus odometer, blah, blah, blah. You see, this doesn't work because when I mouse over get model, it says cannot find symbol because I put that method in Neon, but Neon is a subclass of car. I'm trying to call that method from car, but car doesn't know whether it's a car or a Neon or a Cavalier or a Prius, and only the Neon actually has this method, not the Cavalier, the Prius, or the car. So it gets confused here and says, wait a minute, I don't know what you mean by this get model. So what I can do, and again, notice I'm in class car, what I can do is I can declare the method get model here. I can say public string get model, okay? But what would I return from car? I mean, do I just put in a default? What if I want to force my subclasses to implement this method? If I want to do that, I can do something very strange. Well, it looks strange. It actually isn't strange. I can end this method signature with a semicolon instead of an open close curly, and I can add the word abstract. And what that means is I'm going to define the method here at the superclass level so that it can be invoked on any variable of this type. However, it's going to be implemented by the subclasses because it has to be. An abstract method must be implemented by the subclasses. As soon as I choose save, I have to do one more thing. If I'm going to put an abstract method in a class, I also have to declare that class abstract. Okay, 1 second. So I have to put the word public abstract class car here. By the way, prepare for some quiz questions that have fill in the blanks around this. Say maybe if I left this blank, or maybe if I left this blank, or I left this blank. Think about how you would fill in the blank, because I know I have some quiz questions in the pool that deal with abstract classes just like that. So that would be a good quiz question suggestion as well. Now, something interesting is going to happen. I'm going to move this over here so we can see. I'm going to save, and you're going to see that as soon as I save, the car will compile, but suddenly the Cavalier and the Prius will not. So I save. And there we go. The Cavalier and the Prius no longer compile. And why is that? Because I've declared an abstract class, I have a contract that my subclasses must override this method. So I go into Cavalier, and I mouse over, and let me move back so we can see the actual message here. Vehicles.cavalier is not abstract and does not override abstract method getModel in vehicles.car. So you see, by declaring that abstract, my child classes are now forced to implement that method. So I click implement all abstract methods. Yeah, that's fine. And I could just leave it empty like this, but a better thing to do would be return Chevrolet Cavalier. Okay, terminate with the semicolon. Okay, and now my Cavalier compiles. And now Prius. Okay, we'll do the same thing here. There's the bubble. Okay. Okay, and get model, return Toyota Prius. Since I'm overwriting the get string toString method here, I'm gonna alter that as well. I'll say get model. That way it'll look more like the superclass toString. Okay, there we go, and save. Okay, everything looks good, so I'm going to go ahead and run this again. I'll run it without the debugger so we can kind of do it quickly. And then we'll notice that using our abstract method, that our output messages will be a little more informative. And what's very interesting to note here, is if we look in car, we see that the toString method in car is invoking getModel. And you see, we've only defined the signature of getModel here. We haven't given it implementation. So when this toString method runs and it calls getModel, it's actually reaching down into the child classes and getting the behavior out of the child classes. This is a very powerful concept because it gives you an opportunity to call a method without knowing exactly what that method is doing. It gives you an ability to create a method signature, leave that implementation up to a subclass. The reason why that's very important is we might not have created all of the subclasses of car yet. There might be more that are created in the future, but you see that the superclass car is already set up to reach into the current subclasses and the future subclasses, invoke the getModel method, and find out information or create some behavior, cause some behavior to happen on those subclasses. So I'll go ahead and run. Oops, sorry, I'm in the wrong place. And now I run. We'll create one of each. Okay, neon, odometer 10. Oh, whoops, that was a little low. Gallons of gas 10, miles per gallon, we'll say 20. Okay, more cars, yes. Okay, so this time we'll choose Cavalier. Okay, odometer reading 20,000. Gallons of gas 20. Every once in a while, the J option pane freezes up here, so I might have to restart this. Yep, okay. Let me do that again. One moment. Okay, neon. Odometer reading 10,000. How many gallons of gas? 10. How many miles per gallon? We'll say 25. More cars? Yes. Okay. Cavalier. What's the odometer reading? 20,000. How many gallons of gas? 20. How many miles per gallon? 20. Enter more cars? Yes. Ah, daggone it. There it goes again. Okay, sorry. We'll try it again. Okay, neon. Odometer reading 10,000. Gallons of gas 10. Miles per gallon 10. More cars? Yes. Cavalier. 20,000. 20 gallons of gas, 20 miles per gallon, more cars. Okay, we got further than we did the last time. Prius, odometer reading 30,000, gallons of gas 30, miles per gallon 30. Okay, more cars, and we'll choose no. Now, we see here, probably I should add some spacing, but we see each of our output lines now has the model. Okay, each of the output lines now has the model of the car included. Because while that output line is coming from our car class, it's able to use this abstract method get model to reach into the subclass and pull out some information. That's very valuable. Okay. So, abstract class, a very important concept. An abstract class is usually used when you have that is a relationship. And remember what an is a relationship is. A neon is a car. A Cavalier is a car. A Prius is a car. Okay? It's used where you have this is a relationship and there's some common logic among each of the subclasses, but you do want to get different behavior from the subclasses from a method or a set of methods, and you want to do it in a standard way. So an abstract class where you have a superclass and subclasses with that is a relationship, and there's some common functionality that you want to have, okay? But there are some different behavior you want to get based on the object type. That's when to use an abstract class. One important consideration of an abstract class is that this now changes one thing. We cannot create an object of an abstract class because the abstract class doesn't define the default behavior or the behavior you get when you invoke the getModel method. And remember, variable type tells us what methods we're allowed to call. That's why we put getModel as an abstract method here in car. Object type tells us what will happen when we call those methods. Okay, that's a very important relationship. Okay, so because this method is just defined with the signature, but it's not implemented, we can no longer create an object of type car. Let's see. I will just, in driver, I'm going to delete this, but I'll go ahead and put it in and we'll see why it won't work. Car, this car equals new car. This is going to redline, okay? And when it redlines, what we see is the message is vehicles.car is abstract, cannot be instantiated. So this will not work. If I were to save and compile, this would not compile because an abstract class cannot be instantiated. It can be used as a variable type. And by the way, when I say instantiation, I mean create an object out of it. It can be used as an abstract type, but it cannot be instantiated as an object. Okay? So let me clean this up, and I want to go back to my spreadsheet and explore this again. Let me copy this little grid that we have here, and I'm going to paste it. And again, note to self, you'll probably see something very much like this on the quiz or the exam. This would be a great quiz question suggestion. So I'm going to change this definition over here. If superclass, let's see, if superclass is abstract and is named in our example, car, and subclasses Neon, Cavalier, and Prius. Which of these are legal? This one is no longer legal. When I say we cannot instantiate an object of an abstract class, what I mean is we cannot call the constructor on that class to get an object out of it. So line number one, if car is abstract, line number one is no longer legal. Okay, note the difference between these two. If car is not abstract, hey, no problem. But if it is abstract, we cannot create an object out of it. Okay, and there we go. Now let's take a look at something that is a bit of a topic in object-oriented programming, and that is multiple inheritance. If we look in driver, we see that I have my prompt user method, which is prompting the user for certain information about a car. But then if it's a Prius, it jumps in and it sets some battery charge level and mile per milliamp hour that's specific to Prius. But is it really specific to Prius? Really, it's specific to any hybrid. So what we kind of want to do is we kind of want to make a superclass called hybrid. Unfortunately, we can't do that, but if we could, let me show you how it would work. Okay, whoop, there we go. If I made a superclass hybrid, okay, and then I would put the methods in there. Oops, sorry, I went up to the attribute. Let me get rid of that guy. Okay, then I put the methods in there. Let's see, get MP, MAH, and let's say get battery charge, so on and so forth. Well, you get the point. I'm going to have to delete this anyway. It would be nice if we could have Prius extend hybrid as well. Unfortunately, we can't. Okay, and here's why. Let's see if it'll let me do that. Oh, see, no. Being language independent, I was wondering if Argo UML would let me even draw the line there, but it won't. So the idea would be that Prius has two parents. We can't do that, and here's why. What if hybrid had a method called go distance? And what if Prius extended car and hybrid? Well, no problem, because Prius overrides the go method. So far, no problem. But what about this? Remember what Prius does so that we could reduce our redundancy. It calls super.go, which means I'm overriding a method. And now I want to go up and call that method with super.go. The challenge is if you have two superclasses with the same method signature and you call super, which one does it call? Well, for that reason, there is not multiple inheritance allowed in Java. Okay, and most programming languages don't allow it. There are some that do. But there is an alternative we can do. And this gets back to the idea that the variable type simply tells us what methods we're allowed to call. So really, does the variable type need to have any method definition at all? Or could it just be a collection of method signatures? Well, it ends up that there is a special construction in Java that's just a set of method signatures, and that's called an interface. Unfortunately, that's a not good use of words because people will confuse a Java interface with a user interface. They're two different things. An interface in Java is purely a collection of methods, okay? And so here we go, some information on interfaces and multiple inheritance. An interface is simply a collection of methods, okay? And it's a data type in Java. So since it doesn't have attributes, in UML, it's represented with a two row box instead of 3 rows, because the first row is for the interface name, and the last row is for any of its methods. But there's no need for attributes because an interface is purely a collection of methods. So I can make this interface and call it hybrid. And I can give that methods like get MP MAH miles per milliamp hour. Then I could add another one. add new operation, set npmah, so on and so forth. It's just method signatures. And then what I can do is I can draw a dotted line arrow. Hopefully this one will work. Oh, come on. I want it to go to Prius. Come on, go to Prius. No, I don't want to kink it. I want it to go to Prius. Come over here. Go to Prius. Oh, come on. Okay, maybe we do it. Oh, you know what? How about we just do it this way? Yeah, there we go. Okay, there we go. This is permitted. This is permitted. A class can only extend one class, okay? A class can only have one direct parent, but it can implement multiple interfaces, okay? It can implement multiple interfaces, okay? Now, what's the advantage of that? I'll go ahead and save this diagram. Okay, what's the advantage of that? That interface is allowed to be a variable type. So I can add another section to this spreadsheet. Let me copy this and paste. If superclass is abstract and is okay, that all stays the same, no problem there. Let me bump this. Well, actually, I'll tell you. Let me add a row to just the whole thing. Insert and insert. Okay, if superclass is abstract and is named car, and there is an interface. All right, my spelling's not too good today, apparently. Try that again. And there is an interface named hybrid, which is implemented by Prius. Okay, which of these are legal? Let me add a few more. Hybrid, my hybrid equals new Prius. Prius, my Prius equals new hybrid. Shoot, it's already coloring them for me. I didn't want that. Hybrid, my hybrid equals new Cavalier. Neon, my neon equals new hybrid. Which of these are legal? Let me uncolor them first, and then we'll discuss which ones are legal and which ones are not legal. So first we uncolor them. Okay, hybrid my hybrid equals new Prius. That's legal. An interface can be a variable type. That's legal. Okay? Prius my Prius equals new hybrid. This is not legal because we cannot create an object out of an interface. We can only use it as a variable type, not as an object type. Hybrid my hybrid equals new Cavalier. That's not legal because Cavalier does not implement hybrid. Neon my neon equals new hybrid. Again, not legal because we cannot create an object out of an interface. So there we go. So there's our new set of rules and why. Again, anticipate seeing this on a quiz in the future. Okay, so back to our program then. It seems like we're kind of locking ourselves down in driver if we say if my car instance of Prius. Because we know there are many other hybrids there, and we don't want to have to repeat this if test for every single hybrid. It would be more efficient for every hybrid car, maybe a Civic, a Prius, or any of the other hybrid cars. It would be more efficient to just have them implement this interface, okay, called hybrid. So let's take a look at what the interface will look like. First of all, let's go to Prius and look at those methods. I believe it was get npmah, yeah, and battery level. Okay, good. So we'll make those methods in our interface. So I right click, I choose new Java interface, okay? Class name hybrid. Okay. And here we go. First of all, it has the word interface, not class. It has the word interface. Okay? So what we'll do is we'll say public void set npmah int npmah Now, since we're not giving any definition of this method, we terminate with a semicolon, because remember, the only thing we're allowed to have in an interface is a method signature. We can't actually have a method implementation, or in other words, method behavior. Okay, public void, let's do public int get mpmah. Now notice what would happen if I tried to put some behavior in here. System out print line foo. It won't let me do it. If I mouse over, missing return statement. Well, that's not even, oh, come on. Let me save. Okay, there we go. That's what I wanted to see. Interface methods cannot have body. What that means is you can't have a method signature and then open curly and then some statements in a close curly in an interface. It must be method signature followed by a semicolon. Now that's not calling the method, that's just saying this is my method signature, and any class which implements me must provide definition for these methods. Public void set battery level, int battery level, okay. Public int get battery level. Okay, and there we go. And we save. Now, let's go back to Prius, and to set up a relationship between Prius and interface and the interface hybrid, we have to use the implements keyword. We extend a class, we implement an interface, implements hybrid. If there were multiple interfaces, we could implement multiple interfaces. Let's say serializable. Okay, and I'll need to import that. Okay, so we can implement multiple interfaces by adding a comma. We cannot do that. We cannot extend classes. We can't extend multiple classes. Okay, so see, we cannot do this. Okay, it gets really confused. So we can extend one class. We can implement multiple interfaces. Once again, anticipate a quiz question on this. This would be a great quiz question suggestion. Fill in the blanks here. You could take this one class line and make a whole bunch of fill in the blank questions out of it. Trust me, I already have. So take any of these words, take them out. If we see a comma separated list, we know that can only be interfaces, not a superclass. So if this were the fill in the blank, it would be implements. Okay, if we see a class here and a class here and a blank here, we know a class can extend another class. A class cannot implement a class. A class can only implement an interface. Okay, so extend specifically means one class extends another class. A class can't extend an interface. Now, classes can implement interfaces. They can't extend interfaces. So if we see a class on the left and then a set of interfaces on the right, then the blank to fill in would be implements. So implements specific to interfaces. Extends specific to class. Okay? And that is what's on the right. Okay, now we already have these methods in here, so no trouble. Okay, so I'm going to go back to driver, and instead of my car instance of Prius, I can say my car instance of hybrid. And that's where interfaces are very valuable. If an object implements an interface, we can pass that object into any method signature where the parameter is defined as that interface type. Okay, so in other words, if a class implements an interface, we can basically cast it to that interface type. We can do an instance of operator on that interface type, so on and so forth. As a matter of fact, here, instead of Prius, my Prius, I can say hybrid, my hybrid, hybrid. And remember, again, that hybrid is an interface, okay? Okay. And what we really should do here is probably prompt the user for this information. So let me go ahead and do a JOption pane and say, what is the battery level? String str battery level equals, okay, int battery level equals integer dot parse int str battery level. Okay. Set battery level 12. Okay. String str mpmah equals joption pane. What is the miles per mah? Okay. Int mpmah equals integer parse int strmpmah. Okay, and then we'll pass that in. int mpmah. And up here, int battery level. Okay, and we know that this is going to work for Prius because a Prius is a hybrid, because Prius implements hybrid. Or I'm sorry, I should really say Prius is an instance of hybrid because it implements hybrid. So I save, and now I'm going to run this again, and we'll run with the Prius and a Cavalier and a Neon just to make sure that we that this only runs when we're running with the Prius. So here we go. Okay, Neon, we should not get the prompts for battery charge and miles per milliamp hour. The odometer rating is 10,000, 10 gallons of gas, 10 miles per gallon. More cars, yes. Okay, Cavalier, 20,000 is the odometer rating, 20 gallons of gas, 20 miles per gallon. More cars, yes. Okay, notice we haven't been prompted for battery level yet. Prius, odometer reading of 30,000, 30 gallons of gas, 30 miles per gallon. And here, now, what's the battery level? 12. What's the miles per milliamp hour? 10. Notice this was only prompted on Prius. Okay, and we choose OK. Do you wish to enter more cars? No. All right, I'm a tough guy. Let's make a new subclass then. So let's go over here, and I'm going to right click and choose new Java class, and we'll call this Insight. As memory recalls, that's Honda's hybrid. Public class Insight extends car, implements hybrid. Okay. Now we see as soon as I do that, it gets mad because it says you're not implementing the get model. So I choose implement all abstract methods. And notice what happens. It gets the get model from my superclass car, the abstract get model method. So return Honda Insight. Okay. And then it has my getter and setters for miles per milliamp hour and battery level. An easy way to do that, honestly, would just be to set up the private int mp mah and private int battery level. That would probably be an easier way, and then do encapsulate fields. Give me a second because this is going to redline. I'm going to remove those auto-generated fields. Right click, refactor, and this is off screen, I know, but encapsulate fields. Okay, select all refactor. Okay, there we go. Now we've satisfied our contract with the car and the hybrid. And I'll save that. And I'm going to go back to driver now. I'm actually going to make a couple changes to driver. You might have noticed that I redeclared this array every single time we entered the loop. Probably not a good idea. I might as well do it before the loop starts. That way it's a little more efficient. And what I'm also going to do is add a fourth model, which is our Insight. Okay? This is in class driver, by the way. 3 equals Insight. Okay? And now I need to change my factory method. Okay. And we'll say car type equals ignore case, Insight. Okay. Return car equals new Insight. Okay, and save. Now what we're going to find out, because Prius and Insight are both hybrid, this one instance of operation is going to return true for both Prius and Insight, because they both have that special implements relationship with hybrid. And you know the other cool thing here, did you notice that we're casting my car to a hybrid here? And then we're calling those methods that are specific to hybrid. Set battery level, set miles per milliamp hour. Okay? So we've casted it to hybrid. If I say my hybrid dot, one thing that's very interesting, and unfortunately this went off screen, so let me see if I can bring it back on screen. Notice one thing that's interesting. If we cast a variable to an interface type, it will allow us to call only the methods that are defined on that interface type, plus the methods that automatically get inherited from our capital O class. Okay? So you'll notice that while we've casted it to a hybrid, we can only call those methods that are defined on hybrid, plus the ones that all classes get from capital O. But what's interesting here is that you can actually use an interface to limit the number of methods that can be called. That's a very powerful feature. You can, especially in a case like I work with every day, working for a software company, sometimes there are certain methods that we want to call internally that we don't want our customers to call. And then there's some methods that we want the customer to call to be able to extend and customize the point of sale. Especially in the projects I tend to work on, customers tend to have custom requirements for their point of sale. No two customers are the same. So you need to decide what methods are we going to let the customer access, what are we not. An interface might be a great way to take a class with hundreds of methods and limit it down to only the 5 or so methods that you want to make available. And it's part of its security, but part of it's just simplicity. You might not want to overwhelm the customer with 100 methods. Instead, just give them the 5 most important. So notice, even though the object inside of this is a Prius with a get gallons of gas, set gallons of gas, so on and so forth, the only methods we're allowed to call once we've casted it to a hybrid are those which are defined on hybrid. In any case, a little side note, but worthwhile. Okay? And we save. We also notice that we can implement a method more than once in different classes. Very interesting stuff. So I'm going to go ahead and run. Neon, we know, is not going to call that method. Okay, gallons of gas 10. So we didn't get the what's your miles per milliamp hour. I'm going to choose yes, and I'm going to say Prius. And we know this should allow us to enter miles per milliamp hour and battery level. Sure enough, there we go. Battery level 12, miles per milliamp hour 10. More cars, yes. Now for the first time, we're going to choose our Insight. And because Insight implements hybrid, it should prompt us for miles per milliamp hour. Oops. There we go. Battery level, we'll say 11. Miles per milliamp hour, let's say 20. Do you want to enter more cars? And we'll say no. And here's our output. Neon, Toyota Prius, Honda Insight. Notice that the 2 classes that implement hybrid jumped into this if test. At this point, if you fully understand everything I said, I'd be a bit surprised. Interfaces are a bit tricky to understand, and so are abstract classes. Once again, this might be a good point to go back and watch this lecture again, especially if you were distracted at any point. But I will say that we're going to keep building on this. The next set of lectures we're going to go to are the lectures where either you get it or you don't. Okay? The lectures where if you understand what I'm doing, everything after this will be much easier. If you don't, everything will be fairly difficult. So the next set of lectures I'm going to go through are going to be very, very important. And this lecture today builds on that. We'll see interfaces again. We're going to experience this again with a few more hands-on activities, but those are going to be very cerebral. They're going to be very much thinking activities, not fill in the blank and type this here kind of stuff. It's going to be, here's the best way to handle this situation. One other thought on interfaces. In my Android class, which I'm teaching this quarter as well, on the first day, I always ask the entire class. It's a 475 is the course number, so a high 400 level course. Most people in that class are graduating or very close to it. And so I ask for a show of hands. I say, Who here has had a wildly successful group project here at UC? And usually out of about 25 people, maybe one or two people raise their hands. And then I say, okay, put your hands down. Who here can tell me a good time to use an interface in Java? Not a user interface, but the data type interface. Who can tell me a good use of interfaces in Java? Once again, out of 25 people, about 23 are puzzled and one or two raise their hands. And there's a reason why I ask those two questions together. And this probably seems really far out there right now, but effective use of interfaces is really good for collaboration because we saw here that both Prius and Insight implement hybrid. Well, imagine this. This is how our Android class is structured. One person is in charge of data persistence, one person is in charge of user interface, and one person is in charge of external interactions from the program. So what I have them do is the first phase of the project is everybody has to define an interface which says, this is my contract. These are the methods that I'm going to make. Let's take, for example, persistence, saving to the database. These are the methods that you, the user interface person, can call. I haven't built my class yet, but here are the methods you can call. This is our contract with each other. You can call these methods. So the first thing they have to do is define an interface. The next thing they have to do is define a stub. And a stub is just a simple class that acts like it's doing the work, but it really isn't. So instead of actually persisting data or fetching data from the database, it's simply when the fetch method is called, it returns the same data each time. It's just a stub, okay? It's just something that can be put into place. It can be written quickly, it can be used for testing. It's just, here's what it's going to look like. It's kind of like a quick prototype, if you will, a quick prototype. Then for the rest of the quarter, everybody in class works on implementing the interface with the real class that actually does the work. And then at the end of the quarter, they glue everything together. And because through the entire quarter, they've been using interfaces, they've set up this contract, they can work independently, okay? They can work independently on their own parts. Just provide each other with your interface and your stub, then keep working independently on the real thing, and then at the end of the quarter, we glue everything together based on these interfaces. That way it's not this case of, well, I'm going to work on the project for a few hours, then I'm going to zip it up and email it to you, then you work on it for a few hours, then you zip it up and email it to me. That never works. But with interfaces, since we have a contract, everybody can work independently and then glue everything together at a later date. So, believe it or not, interfaces can be well used to effectively manage multiple person projects. In the real world, as we call it, in the working world after graduation, that's a very, very common thing to use interfaces in that way. It's something you don't tend to see in college because most of our projects are individual. But in the working world, very, very common. So we're at the 48-minute mark or 49-minute mark now. Lots of important things we covered today, abstract classes, interfaces, and the like. We know the next lecture we're going to go through is very important. So I'm going to go ahead and cap this off now, and I'd recommend quiz question suggestions 3 or 4 for the material we covered today. Thank you.